Just a short little video about how to test electric heat trace with a Megger MIT 2500. First thing we want to do is check what Raychem calls a core resistance. So I'll put it on ohms, connect one lead to one of the what are known as the bus wires, the other one the other bus wire. So our core resistance is 7.31 ohms. Write that down, leave it on ohms, connect to the heating cable braid. That should be an open. The next thing we're going to do is test capacitance. But if you get a number other than flukes, say OL, this meter says 1000K. If this is below 1000K, you have a problem already. If it's an open, we can go to measure capacitance. It's measuring in nanofarads. In this case, we have 16.3. Raychem has different values, but you can use basically 5 as your number. So 16 times 5 would be your length. Write that down. Now we go to 500 volts on this meter to test. Same connection, still bus wire to braid. Push and hold that. It starts testing. You can press the hold button and it'll continue pressing. You can see this exclamation going. Let this run. I usually let it run until it stops raising, or in this case, this meter has this arrow that indicates, hey, that's 100%, that's the best you can do. So we write down 100 giga-ohms. Raychem requires 1 giga-ohm at 2500 volts. We just did 500. To stop testing, we press the hold, it beeps. Then it beeps again once it discharges. We'll go to 1000 volts. Again, so it starts at M. You can see that. Starts at M. We're going to hit test. It's warning you it's going to test. Watch, this will change to G. So it just changed to giga-ohms. So we're good, but we let it climb until it reaches a point where it's sort of flattened out. Still climbing. On this meter, 500 volts only goes to 1000 giga-ohms. At 1000 and 2500, it goes to 200 giga-ohms. So we're going to let this guy keep going. It's kind of flattened out at about 150. That's still pretty darn good. So I'm going to stop that test and, oh, there we go, 200. So that's topped out at 200. That's the maximum for this meter at 1000 volts. I'll stop the test. I'll go to 2500 volts. Do it again. Press the button. It's warning you that it's going to test. And we get a high cap. I hit the, sorry. So you get a high cap warning. That means this particular meter, the MIT 2500, has a capacitive sort of preventative measure. They're worried that you won't fully discharge your load. So they put that on there, but we figured a workaround. Still should measure right, but you want to make sure you discharge physically. So we're going to take one of these off. We're going to start the test. It started testing. Now we're going to connect that, and it will continue testing. Now, I don't know if it shows, at 2500, it's arcing because that end has not been cleared. I'm going to stop my test. That's why Raychem requires 2500 volts. So we're going to need to clear that end and test again. Make sure that that has been discharged. You can go like that, something metal. It is definitely, didn't snap, so it's definitely discharged. Get this end. for right click E, you remove 1 inch of the outer jacket. Be careful when you make this cut that you don't go too tight. I make the ring cut and then I bend it to break it open. You don't want to go too hard with that cut, because if you cut the white jacket, it's not going to work. We'll take that off, and for now we'll just hold this back like that. So back to the instrument, release this, press test, grab that again, and we'll let that climb. It's got to charge it up, so you want to wait till it charges the thing all the way up. It does take some time. We're at giga-ohms. We're well above. The one thing we're waiting for is Raychem also says that the readings should be within 25% of one another. So we'll let it get up to 200 if it'll go. You'll see it jump back down and then up. If it just does it once, that's fine. If it keeps going up, down, it's discharging somewhere. You can hear that snap sometimes that, if you're lucky, lets you get to where you need to go. So there you go. That's a good heating cable.